All right, so this is, you might remember like this eye of a very famous like scientist. And now you know that you have this filter, if one at the center, not going to change. If you have one on the right, you know that the image is going to shift towards the left. Now there was a question like the use of multiple kernels, but still we are not there yet, because this is not like a filtering operation. So this is your first kernel, which is kind of saying that, okay, give more weightage to the center pixel. All right. And this is like a smoothing operator or a box filter. Again, trying to normalize this. And you can see that it's 2, because if you try to normalize like all the values or the resultant values, the sum will be 1. Okay, so it's still like a normalized kernel. So this is a very famous kernel, and this performs like sharpening operation. This is called sharpening filter. Okay, so you can see that this image, it was kind of blurry. So this filter is actually bringing back the edges. Okay, and the reason is because it's paying more attention to the center filter itself. All right. So that was the original image, and if you perform filtering using that filter, sharpening filter on the whole image, we'll get something like this. You can see that like all the edges, like in the code here, they are recovered. So this is much better image than the left. All right, some more examples of filtering, and this is, we are moving more towards like extracting important features in images. So far we have seen like how we can perform smoothing operation or maybe remove noise. So this is a very special filter. This is called Sobel filter. It's used for detecting edges in your image. And if you use this for filtering, you can see you will get a result something like this. And what this is showing is, this is kind of showing all the vertical edges present in your input image. Wherever you have a vertical edge, you will get a very high intensity at that pixel location. Similarly, you can, so this is like the edge detection in the vertical direction. You can just rotate this. And again, this is part of a Sobel filter. In this case, we are trying to detect horizontal edges. Okay, so don't worry about like if you don't understand how we are getting horizontal and vertical edges, because we are going to cover that when we talk about derivatives and all that. Okay. So if you perform filtering using this filter on this image, you can see like all these are the horizontal edges present in the input image. Okay, so some key properties of linear filters. If we add the filters, that's similar to like if you perform filtering on the first and then add later. Okay. And again, it's kind of shift invariant, which means that it doesn't matter like where your pixel is located. The output is not going to change. Okay, so you can shift your image first, perform filtering, shift back again. So shifting is not going to change your output. And this is important because if you have an operator which is linear and shift invariant, you can represent that as a convolution operation. Okay, commutative, I think this property we have, oh, we didn't cover this again. So yeah, it came up. The issue is like, we were talking about one is kernel, one is image, right? And I said, it doesn't matter. You can have like this as image or this as image. The result is not going to change. So that's the commutative property. Okay. So you don't differentiate between your filter and your signal. Signal in this case is your image. Associative, we have seen this before. So that's good. And again, so this is also interesting. We saw one example for this, and this goes for the subtraction as well. So if you consider this as a filter, so you are adding 2 different filters and then perform filtering, the result is not going to change if you perform like filtering independently and add the result. Okay. The other interesting operation is about scalars. So if you are like scaling your image, it doesn't matter whether you scale first or you, let's say, you can even scale your kernel. That's not going to change it. All right. In this case, let's say you are scaling your image. In this one, you are scaling your kernel. And in this case, you are performing filtering first and then scaling the result. So all are similar. So this is identity operation, unit impulse. I think we saw one example of this when we just have one at the center. So this is one-dimensional kernel. But you can have two-dimensional kernel where just focus on the center one, so your result is not going to change in that as well.